Situated in the heart of the Santa Clara Valley, bordered by the Santa Cruz Mountains to the west and the Diablo Range to the east, lies the historically tranquil city of Mountain View. In 1955, the landscape changed dramatically with the establishment of Moffett Field by the U.S. Navy. Concurrently, William Shockley, renowned for his pivotal role in transistor development at Bell Labs, returned to Palo Alto to attend to his mother's health. Recognizing silicon's potential superiority over germanium for transistors, a departure from Bell Labs' focus, Shockley founded the Shockley Semiconductor Laboratory in Mountain View in 1956. Despite facing challenges in recruiting former colleagues from the East Coast due to geographical distance and his management style, Shockley assembled a talented team of young scientists. Within a year, 8 of these scientists, led by Robert Noyce and Gordon Moore, departed Shockley's company, citing his contentious management approach, and founded Fairchild Semiconductor in Sunnyvale under the auspices of Fairchild Camera and Instrument. Fairchild Semiconductor catalyzed a transformative era in the tech industry, contributing significantly to the emergence of Silicon Valley. As employees left to establish their own ventures, a cascade of new companies arose, reshaping the regional landscape. By 1970, the burgeoning chip industry in the San Francisco Bay Area employed over 12,000 individuals. The pivotal role of Fairchild and its alumni in spawning numerous spin-off enterprises did not go unnoticed. Journalist Don Heffler highlighted this phenomenon in a seminal 1971 article, coining the term Silicon Valley to encapsulate the concentration of silicon chip producers south of San Francisco. This designation, now iconic, underscores the enduring influence and entrepreneurial spirit originating from Fairchild Semiconductor and its founders. Intel's pivotal role in shaping Silicon Valley cannot be overstated. Founded with crucial backing from Arthur Rock, who had earlier supported the formation of Fairchild Semiconductor, Intel emerged as a cornerstone of technological innovation. Gordon Moore's formulation of Moore's Law, while not a physical law, but an economic principle, forecasted the exponential growth in transistor density, thereby driving computational speed enhancements and cost reductions, a prophecy that underscored Intel's relentless pursuit of advancement. Beyond merely manufacturing processors for PCs and later influencing the cloud computing landscape, Intel defined global software engineering standards. However, Intel's trajectory took a downturn in recent years. Stratacarry's historical perspective underscores a supportive stance towards Intel's success, yet highlights critical junctures where strategic decisions faltered. Intel struggled to transition to 10 nanometers chip fabrication, compounded by hesitations over adopting EUV lithography, marked a significant setback. This reluctance allowed competitors like TSMC to seize the performance lead. Concurrently, AMD, leveraging TSMC's cutting-edge processes, outpaced Intel in chip design, particularly in the data center segment where AMD has been steadily gaining market share. The ascent of hyperscale computing further intensified competitive pressures. These entities not only matched Intel's software advantages, but also possessed the scale and resources to innovate aggressively. Consequently, AMD's advancements in both design and fabrication threaten Intel's historical dominance, with AMD poised to capture a significant share of the data center market. Intel's journey embodies the dynamic interplay of technological leadership and the imperatives of strategic foresight. As the industry continues to evolve, Intel faces the imperative of realigning its innovation strategies to reclaim its historical prowess in semiconductor technology. The competitive dynamics within the semiconductor industry reveal a nuanced landscape where Intel's challenges are underscored by strategic missteps and evolving market preferences. While the focus has primarily been on x86 processors, the emergence of ARM-based server chips has posed a significant competitive threat. Hyperscalers like Amazon have capitalized on ARM's perceived efficiency advantages and lower licensing costs, exemplified by Amazon's substantial investment in its Graviton chip line. Intel's data center revenue decline reflects a broader trend where AI-centric workloads are increasingly driving data center investments. Intel's historical dominance in PC and server markets has not translated seamlessly to AI, where competitors have gained ground due to Intel's slower entry and development in AI-specific hardware solutions. The narrative surrounding Intel's mobile ambitions highlights pivotal decisions that shaped its trajectory. The company's commitment to CISC architecture, under former CEO Pat Gelsinger's leadership, prioritized manufacturing prowess over architectural flexibility. This strategy succeeded in traditional PC and server markets, but faltered in mobile and GPU sectors, where ARM-based designs and specialized GPU architectures gained traction. Despite recent efforts to diversify into AI with acquisitions like Gaudi, Intel faces formidable competition from established players like TSMC, which dominate the production of cutting-edge AI chips. This competitive landscape underscores the imperative for Intel to recalibrate its innovation strategies, prioritizing agility and targeted investment in emerging technologies to regain market leadership across diverse semiconductor segments. In analyzing Intel's current challenges and strategic pivots, it becomes evident that the company is at a critical juncture in its long-standing history. The concept of IDM 2.0, first proposed amid leadership changes and competitive pressures, underscores Intel's recognition of the need for transformative measures. Historically, Intel's integrated design and manufacturing approach served as a competitive advantage, bolstering its market position with high-margin offerings. However, this integration model has increasingly posed constraints on both design innovation and manufacturing flexibility. The company's struggles in advancing to newer semiconductor nodes and meeting customer demands have highlighted the inherent limitations of this centralized approach. The proposal to spin off Intel's manufacturing division marks a significant departure from its traditional business model. This move aims to unlock new growth opportunities by enabling the foundry business to cater to third-party clients independently. While this transition entails building robust customer service capabilities and navigating a complex IP landscape, it aligns with Intel's strategic imperative to enhance competitiveness and regain market share. CEO Pat Gelsinger's advocacy for IDM 2.0 reflects a strategic bet on redefining Intel's role in the semiconductor industry. His vision encompasses leveraging external partnerships and enhancing operational agility to foster innovation across diverse market segments. However, recent deliberations within Intel, as reported by Bloomberg, suggest a cautious approach, considering various scenarios including business separations and strategic asset sales. The urgency of these strategic shifts is underscored by Intel's competitive position vis-a-vis industry leaders like TSMC, who have excelled in delivering cutting-edge semiconductor technologies. Intel's challenges in achieving technological scalability, compounded by recent margin pressures, highlight the imperative for decisive action and robust execution of its strategic roadmap. Looking ahead, Intel faces formidable tasks in scaling its next-generation nodes and solidifying its foundry business as a credible alternative to established industry players. The company's commitment to advancing architectures like Lunar Lake and securing meaningful partnerships will be pivotal in reshaping its market narrative and restoring investor confidence. In conclusion, while Intel navigates through a complex landscape of technological advancements and market dynamics, the pursuit of IDM 2.0 signifies a bold step towards revitalizing its leadership in semiconductor innovation. The core challenge facing Intel and, by extension, U.S. ambitions in cutting-edge semiconductor manufacturing revolves around the viability of Intel Foundry in a fiercely competitive global landscape dominated by TSMC. Key industry players such as Apple, NVIDIA, and AMD overwhelmingly favor TSMC for their advanced chip production due to its extensive investments in EUV technology, superior operational reliability, and proven track record in scaling to 2 nanometers and beyond. Intel's own chip unit, exemplified by initiatives like Lunar Lake, increasingly leans towards leveraging TSMC's manufacturing capabilities. This strategic alignment underscores Intel's recognition of TSMC's technological edge and its pivotal role in ensuring competitive offerings across PC, data center, and emerging technology sectors. CEO Pat Gelsinger's advocacy for maintaining Intel's integrated model reflects broader geopolitical considerations, particularly regarding Taiwan's semiconductor leadership amidst regional tensions. His stance emphasizes the strategic importance of preserving a robust U.S.-based technology provider capable of global competitiveness and resilience. Addressing the future viability of Intel Foundry necessitates candid evaluation and strategic intervention. While the IDM 2.0 approach retains Intel's manufacturing capability under one roof, it faces challenges in attracting external customers while prioritizing internal chip demands. This dilemma underscores the critical need for targeted incentives and policy frameworks to support domestic semiconductor manufacturing initiatives. Proposals for federal subsidies, structured as purchase guarantees for U.S.-produced chips, emerge as a viable strategy to stimulate investment and competitiveness. Such measures could catalyze innovation and market diversification, potentially revitalizing entities like global foundries or incentivizing expanded TSMC operations in the U.S. In conclusion, while the market dynamics favor TSMC's dominance and underscore the complexities of Intel's strategic positioning, there remains a compelling imperative for the U.S. to invest strategically in domestic semiconductor capabilities. This entails not only securing critical supply chains, but also fostering an environment conducive to technological leadership and economic resilience in the semiconductor sector. The path forward demands innovative policy solutions and sustained collaboration across industry, government, and academia to ensure America's continued leadership in semiconductor innovation.